Avocoder. In this lesson, we'll talk about how classes, scopes, imports, and packages work in Java. Some of the designs and concepts will be the topics of the subsequent lessons, so don't worry if you won't understand something from the take one. I promise we'll look into them in future lessons in more depth. Meantime, I will explain the generic principles, what do they mean and how they work in general. So please give this video an Emperor's thumbs up, subscribe to this channel and toll the bell. And so we begin. This is a class. By convention, the name is always capitalized, as well as the first letter in any subsequent word that make up the class name. This is so-called camel case style. The name of the class is preceded by the class keyword. This highlights to the compiler that this construction indeed is the class, and all the elements that make up this class are enclosed between the curly braces. We can see that the first keyword in the class declaration is public. This is an access modifier that we'll study in depth in a coming lesson dedicated to encapsulation. But for now, just remember that public means that this class is publicly available. So the same thing but in code. First of all, at the very top of our file, you can spot something that is called a package. In essence, this is a directory where our class is located, and in our case, it is located in com.avocoder.javafoundations.lesson3 package. The name of the package is something like a family name or surname, to be more precise. That is, the fully qualified name of our class is the name of the class itself plus the name of the package in which it is located. Several classes can reside in a single package, just like in a real family home, and they can refer to each other simply by the name of their classes. But suppose that one of them needs to refer to a class in another package. If this is done only by the name of the class, then the compiler will not know which class is required if it is not present in the same package. In this case, the full name of the class, such as package.name, is used, which is essentially the same as to address someone by their first name and family name. But what if we want to refer to a class by its name without the need of constantly writing a fully qualified name with a package and all that jazz in front of it? This is exactly what the import can do for us. By convention, imports are placed between the name of the package and the rest of the code. Imagine the compiler is like, hey, do you know date? But not the date that is the SQL date, but the one that is in util date. So from now on, when I refer to date and all its methods, I mean the util date. This is what we use the java.util.date import for. So we know that this is going to be a date from the util library, which is in the GRE along with many other libraries. And if we remove the full name of our date without adding an import, then the compiler won't know which date we mean, and our IDE could even make a wrong assumption importing the date we don't want. The class name is followed by a set of curly braces. The code, such as class fields, methods, and constructors, must be enclosed between them. They also serve to determine the scope of certain classes, methods, and variables. Let's have a look at the example. So we have a class called AveClass, which has a couple of interesting things. One of them is a field, which is essentially a variable that belongs to the class of type int, and it's called a with a value of 100. Next is the method, AveMethod, which essentially does nothing and was placed here purely for demonstrational purposes. There is a variable b inside this method of a type int with a value of 10, and also what we can spot inside the method is a code block. You won't see them often nowadays, but yes, it's completely legit to put your code inside this kind of logical blocks. Inside the block we have a variable c of type int that is initialized to 1. This is a great way to illustrate how scopes work inside of our class. Variable A is accessible by all fields and methods anywhere in the class. Variable B from the point when it was declared inside the method and until the method's closing curly brace. And variable C has a tiny scope just inside the purple curly braces. Let's have a look at how it works in code. All constructs within the class have access to the variable A. For example, we can assign the value of the variable A to the variable B, which is declared inside the other method. Then we can assign the result from the addition of A and B to the variable C. But the opposite is impossible for neither B nor C. But what if we'll try to assign the value of variable C to the variable B outside of the block in which variable C is defined? Essentially, it comes out of scope and the compiler highlights to us that it can't see the variable C. Likewise, if we'll try to assign the value of variable A to the variable C outside of the scope of C and the method array method, the compiler will prevent us from doing so, as well as if we'll try to assign the value of the variable C or the variable B to the variable A. But there are syntactical exceptions. For example, the scope of a variable can still be inside of a block, while the variable itself is declared just outside of it, as it happens with a variable in the other method. This is also true for a simple for loop. And of course, we'll study loops in depth later in this course. As you can see, the variable I is declared before the open curly braces, and at the first glance it should have a scope up until the closing curly brace of the class, but in fact its scope is limited to the scope of the method. Please give this video an Emperor's thumbs up, subscribe to the channel and toll the bell. That was V. See you in the next lesson. Bye.